Okay then guys, just a little intro into this section on binomial series. There's 30 questions in this section, and I just wanted to run you through a little bit of bookwork so that you can start the questions and feel comfortable with the subject that we're doing in this section. We're looking at expansion of brackets typically like this, especially in the first instance. 1 plus x to the n, the binomial series is called, and this is the binomial theorem, and this is the series expansion. And so we can say that the binomial series is here. This is version 1. An equivalent version is version 2, when these terms are evaluated. So for example, look at this term here, NC1. Here's the formula for NCR. So if I put 1 in there, it's n factorial over n minus 1 factorial. They cancel to leave n, and this is 1 factorial, which is 1. So it's just n over 1, which is n. So NC1 is n. So you can replace the NC1 by n, and the same goes for these other terms as well. It's not difficult to see that this NC2 is just n minus 1 over 2 factorial. The n minus 2 factorials cancel, in other words, really. Top and bottom. So this is the formula. We either can write it in this form here, which is easy to remember, or this form here, which is also very easy to remember, because there's a pattern that just continues down the row. Generally speaking, if we want to find a specific term, so we want the 20th term or the 15th term, then we would use this form here in 1, because it's easy to read off. But if we're looking just for the first few terms in an expansion of a series, binomial series, then generally this is the form we prefer to write most times. We'd write it like this. So n is a positive integer, so n could be 1, 2, 3, 20, and so on. Any positive integer you like. And we choose these two forms. Now when you do an expansion like this, you'll know that 1 plus x to the n, like when you have squared, you'll have 3 terms, won't you, come out. Here's the 3 terms here actually. When n is 2, you get 1 plus 2x. These 2's cancel. 2 times 1 is 2 over 2 is... So you get x squared plus 2x plus 1. There's 3 terms when n is 2. So generally speaking, you have one more term than you do than the number that is here in the index position. So 1 plus x to the n in general then has n plus 1 terms. So the rth term, if you're asked to find the rth term, they're arranged in this order of ascending powers of x. So the rth term would be the term where the power is 1 less than r. So it's the x to the r minus 1. And when you look at the pattern, you see the term has to be nc r minus 1, doesn't it? So there's the term, and that's the rth term in the sequence. If you want to find the r plus 1th term, then that's when you would look at that one there, for example. And then the third term, well, that would be, if you're looking at this term here, nc2x squared, or you could write n minus 1x squared over 2 factorial. That would be the third term. So that's generally the format and the arrangement and how the things go, and you can choose this or that depending on what you find most easy to use in any given circumstance. Now there's a variation on these binomial expansions, which are brackets which are of this form, because it's very easy to adjust that to looking like this. So let's take an a outside a bracket. So we'll write this as x over a and take an a outside a bracket then. And we've got all this to the power n. Properties of indices, it would be a to the n times this bracket to the n. So the a to the n can go here, and then we can expand this bracket using the binomial series here, binomial theorem, nc0 plus nc1. Now the x, the input x in this case, is x over a. So this would be x over a. So I've written it here. And then it's nc2, input x squared, and then nc3, and so on, all the way up to ncr. Input x is x over a, all to the power r, plus dot dot dot, down to the very last term. Now we can tidy that up a bit by multiplying through by a to the n. So a to the n times the first term, well, it could be written like this, couldn't it? And then a to the n times this. Well, one of the a's gets knocked off the a to the n, so you get 1 power less than n. A to the n minus 1 times x to the 1. nc1. The nc2, well again, 2 of the a's here. The a squared needs to be taken off the n power. We get n minus 2. So you'll notice how this appears. It's very easy to remember as well. A plus x to the n then can be written like so. And you'll see the pattern, it's ncr. The x to the r goes with the ncr. And then these two powers must add up to the n, the number n. So it's a to the n minus r, x to the r. And that's the pattern, general pattern, and all these terms exhibit that pattern as you count from 0, 1, 2, all the way up to n. NCn, a to the n minus n, which is a to the 0, which is 1. That's why there's no a there, because it's just a 1. X to the n, and here it is here. So that's the general formula for a plus x to the n, easy to remember, and the same also goes for these formulas here. And so all the best in this section, guys. As I say, there's 30 questions in this section. Hope you get on okay with them. Best explained by example, so maybe have a little look at the videos for the first few, get a feel for the subject, and then you can go on to the more challenging questions as you work through the section. So all the best then, and I'll catch you in another section. Cheers!